Assalamu alaikum everyone. So today we're going to start another paper of IGCSE. It's 0625 variant 43 of October-November 2025. Let's begin with the first question. Okay, so in this question, what we have, a hard ball is dropped vertically downwards, and figure 1.1 shows the speed time graph for the ball from when it is dropped until it hits the ground, and A resistance is ignored. So this is very important. So A resistance is ignored, and we have this speed time graph. So what we have to tell, describe the motion of the ball in the figure. So what you keep in mind whenever there is when you ignore the A resistance, it's mean acceleration is constant because there is only one force acting on it that is equals to weight. So when there is only weight acting on the object, the acceleration will be because of the gravity. And this can also be seen from the graph. If you see it's a straight line. So this straight line shows a constant slope. It's showing constant slope. And we know in speed time graph, slope is equals to acceleration. So we can simply say that about it. Ball has ball have constant acceleration. Okay. So one mark question, so that is enough. Show that the distance traveled by the ball is 1.8. Now the distance traveled is basically equals to area under the graph for a speed time graph, area under graph. Okay, so what we have to look at the area under the graph. Um, okay, so this is the graph. If I see it's coming here. So this thing is making a triangle. Okay, so we have to find the area of triangle. The base of this triangle is from this point till this point is 0.6, and its height is coming somewhere here between two lines, two domains. Okay, so what I can see, what one point is showing, I have to look at into this. If you see, this is 2, and there are 10 boxes, so I can say 10 boxes are equals to 2 meter per second. So one box is equals to 2 by 10, that is 0.2 meter per second. So if this is 6, the point here should be 5.8. And what we have between 6 and 5.8, so that will be 5.9, right? So that is the height of the triangle. So if I put this thing here, it will give me area under graph is equals to area of triangle. The relation for it is 1 by 2 base into height. So it will be 1 by 2, base is 0.6, and height of the triangle is 5.9. When you solve this thing, you will get 1.77, that is 1.8 meter. Okay, so that is what we have to show. Let's move forward. The mass of the ball is 0.54 kg. Calculate the gravitational potential energy stored in the ball immediately before it is dropped. Okay, so you have to find gravitational potential energy. Relation is mgh. Now we just have to put the values. Mass is given 0.54. It is already in kgs. And g is 9.8. That you have to keep in mind. And h is, we will use this value that they have given me, 1.8. Doing the calculation, you will get 9.5. So your answer is 9.5, and don't forget to write down the units with it. Okay, otherwise you will lose 1 mark. Moving forward, determine the kinetic energy of the ball when it has fallen halfway to the ground. Okay, so kinetic energy relation is, okay, so we don't have to use the relation. What we know, beta, when it is at the peak, this is, let's suppose, maximum height. The only energy it will have, it will be GPE. kinetic energy is zero. When it fall, when it go down, it will lose gravitational potential energy and it will gain kinetic energy. So at the half height, let's suppose it has dropped h by 2, it's mean it has lost half of the GPE and it has gained half of the potential energy at kinetic energy. It's this point it lose half of GPE and gain that is equals to gain of kinetic energy. So as kinetic energy started from zero, so half of Gp is actually exactly equals to kinetic energy. So kinetic energy is equals to gravitational potential energy divided by 2. So what I have for the gravitational potential energy, it was 9.5. In the previous part, we have calculated divided by 2. So that will give me 4.75 joules. Okay. Next part, the same ball is dropped from an aeroplane. Air resistance act on the ball. Now there is a air resistance acting on the ball. Explain how the vertical motion of the ball changes from when it is dropped to just it hits the ground. Use the idea of forces in your answer. So what you have to keep in mind, beta, I'm not writing down the exact answer. First of all, I'm going to explain you the scenario. There is a ball, there is one force that is weight acting on it. This force will remain constant. But there is another force acting on it that is air resistance. What you have to keep in mind, this air resistance force is directly proportional to the speed. When the speed increases, the air resistance force will also increase. Okay, so that thing you have to keep in mind. So how we can write down the answer? So starts, ball start falling with maximum acceleration. Why? Because there is only one force acting on it, that is weight. So resultant force is maximum. There is no opposing force, as only force acting at start is weight. So as speed increases, what we can say, air resistance also increase. And we know resistance always acts opposite to the motion. So eventually, when it keep on increasing the speed, eventually weight is balanced by air resistance and ball reach its maximum terminal velocity. That is the whole scenario, okay? In the next part, a soft ball is dropped by students so that it bounces on the ground. Shows the height time graph for the ball. The height is made from the ground. The ball bounces 4 times. Okay, there is a height, there is a time. Explain why the change in height of the ball between B and C is less than the change in between A and B. So if you see this is A and B, the height is that much. But between B and C, the ball is not gaining the same height. You have to explain this scenario. This is very easy to observe in your practical life as well. If you bounce the ball, you will see it will keep on decreasing the height and eventually it will be at rest. Why? Because every time, let's suppose this is the ground, every time this ball is going to hit the ground, at this point it will lose energy. In which form? In thermal, in sound. Okay. So it's losing energy basically. So when it loses the energy, it will not have enough energy to go back to the original height. So it will go to the lesser height. And again, it will lose energy here and then it will gain less height than before. Then again lose energy here and then gain lesser. And eventually this thing will die off and it will be at rest. So let's write it down. When ball hits ground, some of its energy will be lost as thermal energy. Okay. So object will bounce back with less energy, less kinetic energy, and will not reach same height. Okay, let's move forward. Question 2. A cricket ball is traveled at a speed of 25 meter per second horizontally through the air. The mass of the ball is given. A player catches the ball and the ball came to rest. Calculate the change in momentum of the ball. So you have what you have. You have U, you have M, you have V. V is 0. So how we can do that change in momentum is mass times change in velocity. So that is mass into V minus U. So M is 0.14, V is 0 and U is 25. So doing the calculation, you will get 3.5 with a negative sign kg meter per second. Okay. The player hands are in contact with the moving ball for that much time. This is the time you have. Okay. Calculate the horizontal force exerted by her hands to bring the ball to rest. You have to find the force. So for force relation with the momentum of the time is force is rate of change of momentum. So momentum we have, change in momentum we have minus 3.5 and time we have 9.7 millisecond, that is 9.7 10 power minus 3 seconds. So 9.7 into 10 raised to power minus 3. When you do the calculation, you will get 360.82. That can be written as 360. So this is 360. Write down the units with it. Newton. In question 3, what we have shows a Sankey diagram for the power transformer in a coal-fired power station. This is the total input given to it, and this is the useful output, and these are the losses. These are the wasted energy, right? Power wasted in a station due to thermal, power used in power station, power used in transmission. This is all the wasted. This is the useful energy only. What you have to do, show that the useful power output from the power station is approximately this. So how we can find the useful? Very easy. You can subtract the losses from the total energy, total power. You will find the useful energy. Okay, so sorry, useful power. So useful power output can be equals to total power input minus total power wasted. Okay, now let's write it down. The total power input is 3400 megawatt. Okay, I'm not changing the units because they all are in the megawatt. So I will get the answer in megawatt as well. Okay, so minus all the losses you have to add. First loss is 2200 megawatt. Then you have 40 megawatt. Then you have 25 megawatt. Okay, so doing the calculation, you will get 1135 megawatt. They can written as 1100 megawatt. That is what you have to prove. Okay, calculate the efficiency of the power. So efficiency relation is efficiency is equals to useful power output divided by total input power. Okay, so we just have to put the values. Useful power is 1100 megawatt divided by total is 3400 megawatt, and that will give you 0.32. 0.32. You can also find the answer in percentage if you want. If you want to find in percentage, you will have to multiply 0.32 with the 100. This will be 32%. Okay, so you can also write down 32%. Okay, both are correct. Describe how useful energy may be obtained from geothermal resources. What is geothermal resource? Geothermal is the energy from the core of the earth that you get, right? There is a heat in the core of the earth. You utilize that heat to get the energy. So how we can get that? Basically, water is pumped into the ground and heated. Why it is heated? Because of the hot rocks. By hot rocks. So you have to pump it to a specific point where there are hot rocks are present. So what we can do then? Steam used to turn generators and produce electricity. Okay, let's move forward. Question 4. What do we have in this? A rectangular glass tank contain this much of the liquid. We have the volume. The mass of the liquid is given. Calculate the density. Okay, very simple. Density is mass divided by volume. You just have to put the values. Mass is 2800. Volume is 3. So 2800 divided by 3, you will get 930. And don't forget to write down the units, kg per meter cube. In the next part, a metal block is placed in the tank and it's sink to the bottom. The top surface of the block is 1.1 meter below the surface of the liquid. They're talking about this block, okay? And its top surface, this surface is 1.1 meter from. So the depth in which this top surface is 1.1 meter, okay? And they have given you the dimensions of the block. Calculate the force exerted by the liquid on the top of the block. You have to calculate the force, okay? And it is a 4-mark question. In most of the 4-mark question, you have to use two different formulas. Okay. So if I have to find the force, why there is a force? The force is because of the liquid on the block. So we know when something is placed in the liquid exerts a pressure on it. So I know one relation, pressure for the liquid, that is equals to rho g h. This h is the depth, right? So they have given all the things. So we can find the pressure in the liquid, how much pressure it is experiencing. So if I find the pressure, then what I have to do, I have to find force actually. Another relation I have, pressure is force over area. So I can say force is equals to pressure into area. Okay. And I can put the value of pressure from here to this equation. So I will get force is equals to rho gh into A. Okay. You can rewind this video for the few seconds and you can watch this thing again what I have done. I have just combined the two different formulas and I'm making the force subject. So F is equals to rho g H into A now. So what is the density? Density I have calculated above, it is 930. I'm putting the values of these things here, right? G is 9.8, H is 1.1, and area how I can find, I have these two dimensions. So area of the block is 0.45 into 0.30. So it is 0.45 into 0.30. That is the area. What I have done, and these are the values of the area. Okay. So now let's do the calculation. I will get 1353.43. And when rounding it off to 2SF, it will give me 1400 Newton. What I have done, I have converted this thing to the two significant figures. What is the rule to convert? Basically, you have to see your data. The least number of significant figure in the data will define how many significant figures will be in your answer. So it will be Newton. Don't forget to write down the units for it. Okay. Moving forward, show a part of steel railway track. There are small gaps between the section of the rail. State why gaps are needed between the section of the rail. Explain your answer in terms of particles. Okay, state and explain. Keep in mind you have to explain your answer in terms of particle. First, we have to state why they need it. They need it because to allow thermal expansion, because when they are heated because of the environment or the sunny day, they will get expanded. So when heated. Okay. So we have to explain it now in terms of particles. So we can write at high temperature, particles vibrate with higher speed and take more space. Okay, let's move forward. C part shows a saucepan of boiling water on the heating ring of an electric cooker. The handle is made from the plastic. Explain why this material is suitable. Okay, why you use the plastic? Because plastic is a good insulator. So we can say plastic is a good insulator. So it will not get too hot to touch. You can easily deal with it. Okay. Next question. This is from the wave section. What they're asking, electromagnetic waves have many uses. Draw one line from each choose to the region of electromagnetic spectrum it uses. Okay, so you have to tell which one is used for which purpose. Like security marking. So security marking, we use UV rays. Okay. For the Bluetooth, we use radio waves. These are things that you just have to memorize. Okay. For optical fiber, we use IR and visible light. Okay. Detection of cancer, you use gamma rays. Gamma rays are also used for detection. They're also used for the cure of the cancer. And they can also cause the cancer as well. Okay. So you have to keep in mind these things. Okay, so state one advantage of choosing microwave compared with radio wave to transmit mobile cell phone signals. Okay, so why we use microwave? Because microwave can transmit large data. You can also write it down that they can easily pass through the atmosphere. Okay. So secondly, they need a small antenna to receive the signals. Okay. These are all the advantages that you can write it down. You just have to write down one of them. Describe the difference between transverse waves and longitudinal waves. Okay, so this is very easy. There are many differences. You can write one of them. So transverse waves have crust and troughs, whereas longitudinal waves have compressions and rarefactions. Okay, moving forward to the next part, part C. What they're telling, figure 5.2 shows a simplified diagram of seismic P wave traveling through the Earth. Okay, there is the diagram. The path of the wave are curved. Seismic waves are produced by the rock movement in the earthquake. They're giving the information. State the type of the wave the P wave can be modeled as. So what you have to keep in mind, P waves are the longitudinal waves and the S waves are the transversal waves. So they are modeled as longitudinal waves. Okay. At point X, the P wave travel from the solid mantle to a liquid core. They're changing the medium from solid to liquid. There is a sudden change in direction of the path of the wave. Explain the change in direction of P wave at the point X. Why it is changed? Okay. So when they move from one medium to the other medium, what will happen? They will refract it, right? Why? Because the speeds are changing. So we can write it down. Because wave is refracted due to change in speed of wave. Okay. Then moving forward, the Earth's surface absorbs incoming radiation from the sun and also emit thermal radiation from its surface. Over the past 50 years, scientists estimate that the average temperature of the Earth's surface has increased by approximately 0.75. That thing is called global warming, right? Explain what is causing the average temperature to rise. What is causing? Actually, this phenomena is called the, what you can say, this effect is called the global warming. But why this is happening? This is because of the greenhouse effect. Okay. What we can say due to increase in greenhouse gases, radiations trying to escape Earth's atmosphere are reflected back. So when they reflected back, this is increasing average temperature. So we are receiving more heat and less heat is going out of the atmosphere because the greenhouse gases like the carbon dioxide, water vapors, they will trap the heat. Okay, so the average temperature obviously will increase. That is called global warming as well. For the circuit which include an LDR, light dependent resistor, the LDR is in a brightly lit room. The voltmeter reads 1.8. Calculate the current in the 400 ohm resistor. And it's a 3 mark question. You have to find the current here. Okay, so current will be same in the circuit, in the whole circuit. If I have to find current, I know the relation I is equals to V over R. R I already know, that is 400. I need the voltage. Okay, so what I know here the voltage is 1.84. and total voltage is 5. So we know in series the voltage is divided among the circuits, among the components. So I can say, let's suppose this, if you call this voltage V1, you call this voltage V2. So we know 5 watts that is provided is equals to V1 plus V2. So V1 is equals to 5 minus V2. So this will be 5 minus 1.8. You will get 3.8 watts. Okay. So we get the voltage. Now we can find the current. So current is V over R. V is 3.8. I'm dealing with this thing. Okay. 3.8 divided by 400. So when we divide this thing, you will get 0.008 ampere. Okay, this is your answer. Moving forward, the light level in the room change from bright to dark. State and explain the effect on the voltmeter reading. Okay, what we know, the resistance of the LDR is inversely proportional to the light intensity. Okay, so what I can say, when it's going to the dark, the resistance will decrease. Okay, so in darkness, this R will decrease. If R decrease, the voltage will also decrease. And if the voltage is decreasing for this part, the voltage for this thing, sorry, I'm doing, okay, I'm doing the opposite, sorry. Light is not increasing, light is decreasing. So light decreases, so resistance increase, so voltage will also increase. Okay, so for the LDR, simply, what we have to write down, it's increasing. The voltage will increase. Why? We have to explain as light decreases, resistance of LDR will increase. So due to increase in resistance, LDR will have more share of voltage. What do I mean by more share of voltage? If you see the diagram, this is the total voltage. Some of this will go there and some of this will go there. How much they will have, it will define by the resistance. The more the resistance they have, the more the share they will have from this 5 watts. Okay, so if the resistance of this thing is increasing, it will have higher share and this will have lower share automatically. Okay, of the voltage. Moving forward, part B, what we have in this shows two light emitting diode connected in parallel in a circuit. R is a red LED and G is a green LED. The voltmeter across the LEDs shows a potential difference of 2 watts. Okay, they both have potential difference of 2 watts. Show a current potential difference graph of LEDs. Okay, we have the graph. Determine the current in the ammeter. Okay, so if you see, the total current is coming from here. It will be divided. Some of it will go from here. Let's call I1. Some of it will go there. Let's call I2. So I can say the current in the ammeter is equals to sum of I1 plus I2 when the voltage is 2. They both have the 2 watts voltage. So I have to see when they have 2 watt voltage, what currents they have. So if I talk about this graph, this will be at this point. This is its current. And when I talk about the other one, this is here. It will have that much current. Okay. So now look at this thing. We know these are the 10 boxes. 10 boxes are equals to 20 milliampere. So one box is equals to 20 over 10. That is equals to 2 milliampere. So one box is 2 milliampere. So if this is 10, this will be 12. So, and this is 40, this is 42, this is 44. 4. So what we have I is equals to 12 plus 44. That will give you 56. Don't forget to write down the unit. It's milliampere. Okay, it's given here. The connection to the power supply are reversed, state the reading on the ammeter. Okay, so when you change the connection means there will be a negative now and there will be a positive now. So positive is going to attach on this side. We know this is the reversed biased setting, right? So in reversed bias, if positive side is here, no current will flow through it and no current will flow through it either. So there will be a zero current that is flowing through it. So you can write down 0 and okay, or you can simply say 0. Okay, moving forward, question 7. Question 7 is shows a simple AC generator. Explain the function of the slip ring and the brushes, why they are used. Okay, why they are used. Slip rings, it's just a 1 mark question. There are multiple uses. You can write down any one of them. Slip ring and brushes are used to provide continuous connection. That is their use. In part B, describe how alternating current is generated in the lamp. So what we can write it down, coil is rotating inside the magnetic field of magnets. Magnetic field of magnets. Okay, so they have shown this thing in the diagram as well. These are the magnets and this is a coil that is placed here. So when it will rotate here, the number of line cutting through it will change. So as coil rotates, magnetic field lines cutting through coil, cutting through coil will change. And this induce EMF simply. Okay. State 2 possible changes that cause a larger maximum current in the lamp. Okay, so what we can do, we can increase speed of rotation. We were talking about coil here. Okay, so if the coil is moving more rapidly, there is a more change of magnetic field line and more EMF will be induced. Secondly, what we can do, we can increase number of turns of coil. That is another way. Okay, let's move forward. Part B. Figure 7.2 shows a graph to show how the electromotive force varies with time for the coil. Determine how many revolution of the coil has made. Okay, so when the coil move one complete revolution, this will show you a one complete loop. Here one revolution is completed. Here another revolution is completed. And here is the half. So it is 2.5 revolutions. Okay, so it is 2.5 revolutions. Okay, in the next part shows the end view of the position of the plane of the coil at time 0. The coil is rotating anti-clockwise. It's moving like this. Draw 4 lines to match the coil position to A, B, C, and D, and the coil is viewed from the front. Each coil position may be used once, more than once, or not at all. Okay, so you have to, time is labeled on the graph. Okay, for the A, we have to look at the graph, what the A is. Okay, A is the point where the EMF is maximum. So if the magnets are placed like this, so when the coil is placed horizontally like this, it will have the maximum lines passing through it. And this is the point 0. When the coil is placed vertically, so it will have minimum line passing through it. Okay, so how we can do that, this thing? A is for the maximum, should be horizontally, and B was the minimum, it should be vertically placed. Okay. And let's see what the C and D is. C is again 0 and D is again another maximum. So C is again 0. So 0 is for this thing. And we know D is again maximum. So maximum is for the horizontal. Okay. This is how you can label them. Okay. Now question 8, it's from the nuclear physics. What we have, alpha particles are directed at a very thin sheet of the gold foil. The following observation provide evidence for the nuclear model of the atom. State what is State what conclusion may be made about the model of the atom from these observations. This is from the Rutherford experiment. Okay, so observation was most of the particle pass straight through the coil. This was the observation, and what we have concluded from there, the conclusion was most of the atom is empty space. That was the conclusion. In the B part, observation, a few particles bounce back or are deflected through large angle. You have to tell the conclusion. So from this, what we have concluded that nucleus have positive charge. Okay, that is the reason why they are deflected. Then part B shows three beam of ionizing radiation, alpha, beta, and gamma, passing between two parallel plates. The plates are charged and there is a uniform magnetic field between them. You have to state and explain which path PQR shows a beam of alpha particle. Okay. If you see, this is the gamma particle because gamma is neutral. You have to choose between P and R, which one is alpha. If you see, R is bending more, whereas P is bending, but it's bending less. So why it's bending less? The more the massive things bend less. You need more force to bend the massive object. So alpha is massive. So this P is alpha. Beta is lighter than the alpha, so it will bend more. So we will write down P and we will explain it why alpha particles have greater mass, so are deflected less. Simply. Okay. Let's move forward in the next part. State and explain the direction of electric field between the plates. Okay, so what can be alpha is going there. So alpha move towards the negative. So this should be negative, this should be positive. So what will be the electric field line? They go from positive to negative. So electric field lines are upward. So how we can explain this thing? First we have to state it is upward. Then we have to explain. So we can write alpha particle attracted towards negative plate. Okay. Then there is a C part. Curium 42242 is a radioactive isotope. It emits alpha particle. Its half-life is this. You have the half-life of this. After 480 days, the mass of sample remain is this. Calculate the initial mass. Okay, they have twisted the question. They have given you the remaining mass and they have asked you the original mass. Okay, what you have to do, but keep in mind these relation what I am writing down here. Number of half-life. This will make every question very easy related to half-life is equals to total time passed and divided by one half-life. Okay, when you do this, you have 480 days passed and half-life is 160, you will get 3. So you have three half-lives. Okay. Now there is another relation that you have to keep in mind. Second relation is of mass after three half-lives is basically equals to initial mass. If there are three half-lives, then it will be divided by 8. So what we have basically this thing. We have to find this initial mass. So initial mass, let's call this M. So M is equals to 8 multiplied by mass after three half-lives, and mass after three half-life is this 8 into 2.4 into 10 to the power minus 3. So this will give you 0.0192. 0.0192, and don't forget to write down the units, it's grams. Moving forward, this is from the space physics. Cosmic microwave background radiation, that is called CMBR, can be observed in every direction in space. State when CMBR was produced. So CMBR was produced when the universe was created, or you can say after Big Bang. Okay. State and explain how the wavelength of this radiation has changed since it was formed. Okay, as the universe is expanding, the universe is cooling down, and at a low temperature, wavelength is high. Okay, so you can state wavelength is increased. Why it is increased? We can say universe has expanded and cooled. Okay. In the next part, table 9.1 shows data about the planet in our solar system. This is the data they have given. What they're asking, the orbit of the Venus is approximately circular. Calculate the average orbital speed of Venus. Give your answer kilometer per hour. So orbital speed, we know it is equals to 2 pi r over t. I need the radius of the Venus. So average radius they have given in 10 power 6 kilometer, and this is the time they have given, but this is in years. Okay, so I need kilometer per hour. So R is correct. R you can simply write down 2 pi R is basically 108 10 power 6, and it is in kilometer. You have to keep in mind. T you have to convert. T is basically 0.62 years. You have to convert into hours. So 0.62 into 365. In 1 year, there are 365 days, and in 1 day, there are 24 hours. So it will be like this. So it is 0.62 into 365 into 24. And doing this, you will get 124,941.82 kilometer per hour. You can simply round this thing to the 2SF. This will be 120,000. Okay, kilometer per hour. Units are already written there. In the second part, state how the average surface temperature of the planet change as its distance from the sun increases. When you move away from the sun, the temperature is decreasing. Okay. In question 10, this is also from space physics. Sketch a diagram to show the orbital path of a comet around the sun. Okay, we know the comets move in a elliptical path, and sun is not at the center. You have to mark the sun as well. So there will come a S. You can add an S here as well, but you have to choose one point. In B part, draw a cross on your diagram to show where the comet is traveling with the slowest speed. Label the point N. A comet will be slowest at the highest distance when it is far away from the sun. Why? At that point, they have the maximum GPE, least kinetic energy, so their speed will be less. Explain why the speed of the comet change as it travel. Okay, then you have to explain it, and explain why the speed use the conservation of energy. Okay, so how I can say that when comet move close to sun, what it will do, its gravitational potential energy decreases. Okay, its kinetic energy increases as total energy is sum of kinetic energy and gravitational potential energy. So if one increase, the other will automatically decrease. So we can say when comet have more kinetic energy, it will be at higher speed. Okay. So we are done with this paper. Don't forget to like, subscribe the channel and share with your friends. See you in the next video, inshallah.